I went to Africa. I met this group of boys with 12-year-olds, and one of them were very popular. I asked, "Why are you so popular?" And he said, "Can't you see? I have long sleeves." Took his shirt off, rolled it together in sleeves, made a knot, and that became a ball. And that's how they could play soccer in the streets. They were traumatized. They lost friends and family members in the war. And they wanted one thing: the opportunity to play.
For this case study entitled Engineering Your Future, we have Troy Carter, founder at Rhizome. Troy will talk about advancing the use of engineered bamboo lumber as the primary material in construction, the practical use cases and benefits of using this material, especially in the Asia-Pacific region, and Rhizome's carbon sequestration goals to build a more sustainable and responsible future.
Hi, my name is Troy Carter. I'm a co-founder and chief strategy officer at Rhizome. At Rhizome, we're pioneering the use of bamboo engineered lumber as a climate-positive alternative to wood, steel, and concrete. In this presentation, I'll be talking about how Rhizome is building a robust supply chain for bamboo, turning it into a modern construction material, talking about some of the sustainability and ecological benefits, and answering some questions that you may have around design and how to actually use the product. At Rhizome, we have a hypothesis that bamboo will become one of the most significant construction materials, and the reason is pretty simple. One, it has to happen. So global construction is an ecological disaster. Concrete and steel make up a huge portion of the Earth's CO2 emissions, and wood is harvested sustainably all around the world. Most deforestation is due to agricultural conversion and land use, but also the timber industry is a huge contributing factor. All over equatorial regions of the world, over the last 50 years, we've seen almost 100% deforestation. Go to India, Indonesia, Philippines, a lot of Southeast Asia, Sub-Saharan Africa, Central America. There's been massive deforestation of biodiverse, rich tropical forests. And so we need an alternative to cutting down native forest for wood products. And because there's going to be so much population growth in most of these areas, all of those buildings will be built out of concrete and steel unless there's a viable alternative. Because there's not enough wood to actually supply these new buildings, bamboo is one of the only viable construction materials to actually grow a climate-positive built environment. So how does this actually happen? One is that bamboo is the fastest growing plant on land, and it sequesters carbon dioxide from the atmosphere, puts it into biomass, into soil, into below ground biomass, the root and rhizome, and then we harvest it and put it into the built environment. It's super fast growing, which also means that it takes 12 times less land than most temperate forest, which means that the trade-off between building more and preserving native forest and biodiversity is just a lower level trade-off. So we can harvest the same amount of building materials on less than 10% of the land. It's also a really technically superior material to wood. So it's got 2.5 times the strength to weight ratio of steel, which means it's super strong. It's about twice the strength in almost every metric as Douglas fir. It's also fire resistant. So that means when we're building with wood, The main reason we haven't built large mass timber or bamboo skyscrapers or wood skyscrapers in the past is because of fire resistance. With our product, it's got the only Class A fire rating of any biological product out there, which means that we can have huge exposed beams that don't burn. So how do we actually go make this stuff? So right now, Rhizome is mostly active in the Philippines, and we export nearly all of our product to the United States. Our production is growing significantly, and in a couple years, we'll be shipping globally, meanwhile planting forests all around equatorial regions. So step one, we're doing a lot of planting and harvesting. So we partner with hundreds of different small farmers and indigenous groups to supply really large bamboo poles. We use Dendrocalamus asper, Sinicus, and giganteus, which are the 3 largest bamboo species on Earth. We put it through a proprietary process, which means we split it, we plane it, we treat it, and we dry it so that it becomes a dimensionally perfect and stable, long, about 3.2 meters long, 10 by 35 millimeters in dimension. Then we glue it together into pretty much any configuration that you can have. So our base product is a 1/4-inch piece of plywood, but we also do layups for boards and dimensions and other interior furnishing products like trim and specialty products for doors, windows, and flooring. One of the big thresholds that bamboo has to reach in order to be globally relevant is price. And we don't want developers and builders have to make concessionary purchases to choose bamboo over wood. We'd realize that that's not actually a realistic choice for most people. Most buildings are built based on what is the fastest, cheapest, and highest quality. So pretty soon, in 2021, we anticipate that bamboo lumber will reach price parity with wood for most structural applications. It's already cheaper for hardwood replacements, like if we're replacing oak or poplar or maple. It's a clear aesthetic finish, which means it looks gorgeous for windows, doors, flooring, wall paneling. And more, we will be entering the structural market to provide CLT, LVL, and other mass timber and engineered lumber applications. So why is this important? Why should we start choosing bamboo? And Rhizome is on a mission to draw down carbon dioxide from the atmosphere because we are in a climate crisis. We are just starting to see the initial implications of. Bamboo is the best technology we have to draw down CO2 from the atmosphere, and the built environment is the largest man-made area for sequestering carbon that we know. We can also do geologic carbon sequestration, but plants are the best technology we have. And our internal goal is to draw down 10 gigatons of carbon, which means 10 billion tons of CO2 by 2050. In order to do that, we're going to have to plant more than 1 million hectares and have that under harvest, which means we need more than 1,000 processing facilities globally. Right now, we're essentially in pilot phase. We operate 2 factories in the Philippines. We'll be building a third shortly. But in order for the global construction industry to transition into a climate positive industry rather than a climate catastrophe, we need to start using materials like bamboo. Mass timber is also really great, but the data is a lot more ambiguous about whether it's actually a climate positive material. When you cut down a tree, the tree dies. When you cut down bamboo, the rhizome and the root structure actually just sends up a new shoot. So for soil health, for keeping carbon locked in soil, it's really important that we use regenerative or coppicing plants. If you would like to contribute to this movement, how do we make the built environment climate positive? Please reach out. We're always looking for strategic partnerships with funders, with forestry companies, with builders, architects, designers. We're doing a lot of design collaboration because till now, Bamboo has been an academic material, right? Everyone's known about its strength and fire properties. It's an amazing material for cottage industry products like toothpicks and chopsticks and cutting boards, and we're optimizing for large, which means that this is the first time in history that we are dimensionalizing bamboo and turning it into a commodity product just like any other piece of plywood. So more and more designers and architects and engineers are going to start discovering ways to build buildings that actually take advantage of the really sophisticated mechanical characteristics of the bamboo. That means we can have bamboo hybrid softwood CLT, means we can have huge exposed mass timber beams. We can move to panel-based construction versus stick construction or stud construction, which means that because bamboo is so strong, the wall paneling actually holds up the building versus studs holding up the building with sheathing. So there's a whole bunch of ways in which also prefab building becomes more efficient, or the fewer Lego blocks that we need to put into a prefab system, the faster and cheaper that system. And so because bamboo is so strong and fire resistant, it can serve multiple uses in the same building. It can be an aesthetic surface, it can be a walking surface, it can be a tension layer for a piece of CLT, and each of these uses allows it to perform it performs multiple functions in a wall or in floors. So we can have integrated flooring that's refinishable on a CLT member that's way smaller, so you get actual more surface area for usable space. But if you want to do design collaboration, know more about the specific technical specifications in the material, please reach out. We'll send you a lot of testing data and then work with you to implement new designs. Right now we're selling to pretty much all interior uses, for flooring, for walls, for cabinets, for furniture, and that's just because of the higher value use as a hardwood replacement. But over the coming years, as large buildings start going up that are made out of wood, anything that you can build out of wood can be built out of bamboo, and better. We've known in academia for a long time that bamboo are light, very fire resistant, really regenerative, climate positive. We've known this, so why hasn't it actually developed into a sophisticated supply chain like wood lumber? The biggest element is that bamboo grows in equatorial regions, and most of those regions have been primarily operating in Mindanao in the Philippines, and there isn't much in the rural, agricultural, local economy. So in order for us to develop a rigorous supply chain, we need to plant a lot of bamboo. We need to upgrade the manufacturing capacity of actually processing that bamboo, and we need to create sales channels so that when a developer actually orders 10 containers of plywood and with very specific quality requirements. So let's talk about planting. One, bamboo is really easy to plant. You essentially take a node cutting, which means you cut up a very long 30 to 40 meter culm into 3-foot pot, or you put it into a ground. We only use non-invasive, non-running species of bamboos. We only use clumping bamboos, which means that the plant stays where you plant it and has great, basically, ecological benefits where you plant it. So soil erosion control, nutrient regeneration, CO2 absorption, basically building up the soil and building up the health of the forest. So we need to do a lot of planting. Our internal goal is to plant more than 1 million hectares of bamboo by 2050. And that means we have to be planting all around the world. That means sub-Saharan Africa, Southeast Asia, Central America, and most of these regions, particularly in South and Southeast Asia and Sub-Saharan Africa, we've seen almost 100% deforestation. And so the use of bamboo for reforestation is a step in restoring local ecology. So as an anecdote, there have been major tree planting efforts and that's because of a few factors. One is the ecological and biological factors. When you plant a tree, it's a very fragile plant, and so if a grass fire comes through or an animal chomps the stem, the tree dies. Bamboo is not quite like that. It's a very hardy plant. So when you plant it and there's a grass fire or a cow chomps it, it can still grow. Water restoration, soil restoration, and create fire breaks for new is important financially for local people to be incentivized by what they plant. So if you're planting a hardwood forest or other native forest, mostly that forest won't be economically viable for local or indigenous people for 40 to 50 years. And so we need to introduce agroforestry products like bamboo so that people can start seeing a return on their land, so they're not forced to cut down the trees early or continue cutting land for agricultural use, ranching. And that's mostly what we see, actually, is that it's not for the wood. People can't wait 40 or 50 years for wood, so they continue, and most deforestation is actually through land use conversion from agriculture. So we need to have agroforestry crops that are both good for biodiversity and good for wildlife, and that serve the economic interests of local people. Another element that's important about bamboo in a way that's different than other forestry projects, inherently product. Imagine going to a forest, getting a full-size Douglas fir that's 4 feet across and trying to cut it down and process it yourself. That's an impossible task. It's just too big. It has become very centralized because you need very expensive equipment and highly efficient process, different with bamboo. So with bamboo, particularly in rural areas, people with 1 acre or 5 acres or harvesting in wild forests can bring the poles to the factory, get paid that day, achieve food security, and have not lost anything. Means the crop is still there. It'll grow back within 18 months. And so it's an amazing high value crop for local people to participate in with very low technology requirements. At the factory, we have 2 stages of processing. The first is remote or rural slat processing, where we're essentially taking the round poles of bamboo, we're cutting it or splitting it into long slats, planing them and treating them into essentially a dimensionalized product that we can take to a higher together, sand them, plane them, so that it's dimensionally perfect and stable lumber. The first part of the processing can be very low tech, so we can have splitters and cutters and planers in a very rural location that local people can operate themselves. So build, operate, transfer model where, because of our expertise, we help set up for a couple years, and then we're able to transfer it to a local co-op to continue operations. And that's a great model for us to be able to scale, to use our expertise to support local groups to have a sustainable operation, and then be a great customer long term, so that and a reliable enough supply chain is the fundamental has stopped bamboo from becoming a major industry so far. So bamboo's been optimized for chopsticks, toothpicks, sometimes flooring, but it's never been optimized for large uses and larger interior uses. That's essentially what we're doing. Species for size and growth rate. We're optimizing the production process with custom machinery so that we can make the largest and we're optimizing for automation and efficiency so that we can get the costs down. And most of our customers are large lumber companies or industrial interior furnishings, making walls, windows, doors, flooring, things like that. And billion-dollar companies who are doing 100 a week or every month. And in order to be relevant to them, we need to have much larger production. And essentially what we're doing now, which is a pilot project and full industrialization, needs a lot of money and needs time and regulatory changes in code compliance so it can become a universal building material. Right now, the best bamboo in the world is in the Philippines, and then there are some other great parcels in northern Thailand and East Timor, a little bit in southern China, but the giant bamboo is pretty rare still. So we essentially need to plant all around the world. And right now, there's no sustainability initiatives like FSC or SFI that we think accurately assess whether bamboo is sustainable. So we basically use our own internal data verification this issue. One is that bamboo is pretty hard to harvest unsustainably because it grows back. It's a grass. It's just like mowing a really tall lawn. You can over-harvest it and decrease shoot production, but it's really just cutting into your own future harvest potential, but it's not killing the plant. So one, we need to come in and be able to verify sustainability in an easy way. Also, because bamboo is pretty decentralized, we need those to work with very large co-ops of people. So right now, Rhizome's really doing the only sort of like rigorously world, and so we can talk more about how to source that sustainably. Most bamboo in the world is not giant bamboo. So India, China, China has 35 million hectares of moso, which is just a lot smaller. And it's a great bamboo. It grows super fast. It is a running bamboo, so it's not something you want to export to other places. And it also won't that we need in order to be competitive with conventional wood plywood. And so that's why we have to use a really large species. And so when we're planting in new areas, we are planting non-native species. And that's a strong consideration for ecologies in those areas. We do not want or species that will start occupying ecological niches that push other species out. So we own bamboo, and we believe that, human civilization is a trade-off, right? So the more we build, the more air in order to provide those building materials. But because bamboo grows so fast and so dense, we need less than 1/10 of the land that's necessary for growing temperate forest. So we believe that bamboo has a very strong role in of the ecological trade-off for buildings. So maybe just giving a case example, illustrate this point. So India, Bangladesh, these are countries that will see massive population growth over the next 40 years. The US, Western Europe, Scandinavia, we have almost all the buildings that we will have in 2060 already. And so how developing can grow their buildings is an essential step. So right now, because these areas are mostly deforested, these buildings will be built out of steel and concrete unless there's another alternative. And right now, that alternative is bamboo. So India, Bangladesh, Southeast Asia, Sub-Saharan Africa, they're bamboo plantings now, so that in 7 years we can come in, or other partners can come in, to build factories to grow materials locally and use them locally and have sustainable, circular, local building material industries, which right now is a very global market. Shipping in wood from North America, shipping in concrete, and steel from all around the world, got a huge cost. So maybe we talk about price for a second. Developers and building managers, that in the end, price is probably the consideration that you will choose one building material over another, even if it's sustainable. And so bamboo price any other building material choice that you have. So it's a non-concessionary purchase, and that there won't have to be any other design changes. You can just click in bamboo where you other wood product, CLT, plywood, wall sheathing. And so that will happen pretty quick. Right now our biggest hurdle is scale. So we're scaling up very fast. We're building a factory that's 10 times larger than our last one right now. But it's going to be a few years before bamboo materials are widely available. And in 7 to 10 years, we guess that bamboo will be significantly cheaper than any other building material on Earth. That is a few reasons. So one is scale. So competitive with wood and quickly becoming price competitive with even low quality softwoods. However, bamboo has not been optimized for lumber production. So one, we are choosing the top 0.1% of plant genetics to propagate. Long-term impact on wall thickness and dimension of bamboo, which will lower cost of materials by almost half over the next decade. We'll also be releasing additional iterations of our manufacturing technology for more automation, faster processing speeds. So there's utilization, and then price just goes down. Also co-locating plantations being cost, and then also using the building materials in country rather than shipping all the product to the United States, which is what we're doing. Great margin on products in the United States. However, the end goal needs to be countries will produce their own material. Let's talk a bit more about carbon. So the carbon market has changed a lot in the last few years. More and more we're seeing companies, big companies like Microsoft, Amazon, Stripe, really leading the way with carbon offsetting. And there's a bunch of different ways which you can offset carbon. You can buy sort of like conventional carbon offset regulatory market or a compliance-based market, and when you have to buy offsets. But there's a really, really big difference between carbon removals, which actually physically in the atmosphere and puts it in a forest or into a building, and an offset, which is more of an account. You build a solar plant or a dam, but you don't actually physically remove carbon dioxide from the atmosphere. So we believe that nature-based carbon, the highest quality and most holistic way of addressing climate change. And we have nature-based carbon removals that actually have a useful end product, high greenhouse gas product. And so we get an additional at least 40% bonus from replacing wood, steel, and concrete. And bamboo is the fastest growing plant on Earth, which means it's really, really efficient at. So we believe that with more than about a million hectares of bamboo, we can sequester 10 gigatons of carbon by 2050. So in general, what can the property and construction sectors do to help fight the climate crisis? One is, building environmentally friendly buildings that are low energy to operate. And most most calculations right now show that we can reduce at least 90% building operational costs and energy costs by doing better insulation, renewable energy. But that still leaves about half of the energy in a building unaccounted for in embodied carbon, which means we need to change the building materials that we're building with. So building with wood is an awesome technology. It's approximately carbon neutral, but more recent data shows that actually forestry is maybe it's not as sustainable as we may want it to be. Half the carbon, so the roots die, the soil gives off a bunch of carbon, and basically has a detrimental long-term impact to forest health and growth rates. So what we suggest instead is using bamboo, where you can cut, and that you can cut a third of the clump every year. So it's essentially a very efficient machine for taking CO2 from the atmosphere, putting it into a plant, and then the plant turns into a building material. So maybe some use cases around you. So one, we're doing pilot projects all around the US right now and Canada. Our launch market, particularly for interior uses, and then pretty soon starting with structural uses. Thank you so much. Please reach out if you're interested in doing a pilot project, learning more. Let's start the project together. We're looking forward to hearing from you. Thank you so much.